Here is a few selected slides from an external presentation I created covering production profile logging. The entire presentation covered a number of aspects. The following selected slides address spinner interpretation. First, I covered the two-spinner pass method, showing the method of maximum separation to identify 100% flow. Likewise, where there is no curve separation, there is no flow. Then, at each zone, the percent flow can be computed by determining the amount of separation between the curves. A more involved method of spinner interpretation involves cross-plotting spinner response against logging speed. In a static fluid, these points will define a line that passes through the origin. As fluid movement occurs, the line defined by the data points will move to reflect the fluid velocity. Static frictional effects result in the two distinct lines separated at the x-axis with the fluid velocity approximately equal to the average of the two x-intercepts. This is a few slides from an internal presentation I created as part of a log analysis class. These slides deal with magnetic resonance imaging physics. First slide introduces the concept that hydrogen protons are precessing around their magnetic pole and that they are oriented with the Earth's magnetic field. The frequency of their precession is dependent on the magnetic field strength and is known as the Lamarr frequency. This slide shows that the hydrogen protons will align with the Emerald tool's magnetic field and that their precession frequency will increase due to the stronger field. Also introduced on this slide is the fact that the field strength and thus the frequency decreases with increasing distance from the tool. This slide covers the quantum physics of the measurement, showing that an RF pulse adds energy to the system, causes a phase coherency and a rotating magnetic field at the Lamarr frequency. Since the RF pulse has a spectrum width and the magnetic field decreases with distance from the tool, the proton spins will dephase. The basis of the CPMG pulse technique is alternating 180-degree pulses. Alternating pulses causes the spins to reverse. When the protons align, a resultant RF pulse can be detected. To continue the measurement, the 180 pulse is repeated. The final slide shows the CPMG pulse method, and the effect is the hydrogen protons interact with their environment. This results in a loss of energy and in turn a decay in the received signal. It is the rate of decay that is the principal measurement of the MRIL tool.